So now we're going to talk about determining whether a point is on the graph of an equation. If you missed the graphing equations by plotting points, go back and find that one. Um, we are still in chapter 1, section 1, and we're going to look at a linear example. So let's go here. Let's say we have an equation 2x. Move that back. 2x minus y is equal to 6. And you're asked whether to determine whether the point 2, 3 is on the graph of that equation. We know in an ordered pair that this is telling you that x is equal to 2, y is equal to 3, and we're going to plug those values in. So 2x minus y equals 6. You're going to see when there are negatives that it's important to use those parentheses so you don't drop negatives. It's a really easy mistake to make, so we're going to make sure we don't do that. So 2 times 2 gives me 4 minus 3, and we get 1 is equal to 6, which doesn't make any sense. So what that means is that the point 2, 3 is not on the graph of this equation. Let's try one more. So again, with the same equation here, 2x minus y is equal to 6. Let's say we're trying to see whether the point 2, negative 2 lies on that equation. Again, 2x minus y equals the 6. I plug the x in, which is the 2. I plug in negative 2. And what I see is 2 times 2 is 4, minus a negative makes it plus 2 equals 6, and 6 is equal to 6. This, on the other hand, is true. So what that is saying is that the point 2, negative 2 is on the graph of that equation. And this tells us how to determine whether a point is on a function or equation. Going on, we're also going to talk about how to express an equation as y is equal to x. So we want to see it in terms of x. So for example, if we have the equation 2x plus, let's try this again, 2y plus 3x minus 5 is equal to 4. Now, this is called an implicit function, meaning the function is implied. To get y equals, this is going to make it an explicit function. And those terms will come up more next year when you're in calculus. But it's important to be able to see that that's still a function, even if it's not in a y equals form. Another reason to be able to translate an equation into y equals an expression is because of the graphing calculators. Now, you've got a lot of tools out there that don't care to get your y by itself, but some of them still do. Most of the graphing calculators start with y1 equals, and this is where you plug in your expression. So you've got to isolate the y in order to put it into those calculators. So what we're going to do is isolate the y. We add the 5 to both sides. 2y plus 3x equals 9. I'm going to subtract that 3x from both sides, giving me 2y equals negative 3x plus 9. Last step, dividing by 2. This is going to give me both sides by 2. Y is equal to 3 over 2x plus 9 over 2. Now, leaving it in, sorry, I lost the negative. Leaving it in this form, the negative 3x plus 9 over 2, that's okay as well. I turned it into y equals mx plus b just because we have a lot of clues on how to graph and what it looks like based on y is equal to mx plus b, but it's not necessarily required. Let's look at another example. And let's make this go away. So let's say we have, let's take that circle we looked at earlier. X squared plus y squared is equal to 4. Now, you noticed when we graphed this before that it was a circle, which means it's not a function. So even though it's not a function, we can still graph this on a calculator. In order to do that, we still want to get it into y is equal to something. So we isolate the y. We move everything away first, leaving us with y squared is equal to negative x squared plus 4. I want to get the y by itself, not just y squared, so I square both sides. Now, we talked about a little bit how if the variable is squared and I take the square root, I have to account for the fact that both of those values could be positive and negative. So we've got y is equal to plus or minus the square root of negative x squared plus 4. Now, again, if we're looking at a calculator, what's going to happen is you're going to have y1 equals and y2 equals. You're going to have to break this into two different equations. So we're going to have y is equal to the square root. If this negative bothers you, move it. 4 minus x squared. And then you're going to have the opposite of 4 minus x squared. So putting it into a graphing calculator, you're going to need to be able to isolate the y. Translating between implicit and explicit functions, you're also going to have to be able to isolate the y. So where are we on our list? We've done, pencil's not working again, the first 3. So we've got one more to go. I think I'm going to break this into a second video. So look for, or third video actually. So look for that